the strong force was more or less, that could have been an issue forming the nuclei of all these elements that we have in the ordinary matter, right? So all of this stuff actually affects our everyday life very, very much. So we'll see. We'll see what this section holds here. So, for example, the existence of the stable nuclei forming the 100 or so elements of the periodic table hinges delicately on the ratio between the strengths of the strong and electromagnetic forces. The protons crammed together in atomic nuclei all repel one another electromagnetically. So guess what? The protons in all these nuclei, and of course, the heavier the electron, or sorry, the heavier the element, the more protons you're going to have in that nucleus, right? Of course, the heavier elements also have neutrons, but basically protons have a charge. It is they're all positively charged, so this positive charge will repel each other electromagnetically. But thank goodness for the strong force, otherwise that would have been an issue. So how come we have the very strong repulsion between protons in a nucleus, but somehow they still are in the nucleus together forever happily, right? In stable nuclei of stable elements in the periodic table. Entire chemistry, is hinging on that. So the protons crammed together in atomic nuclei all repel one another electromagnetically. The strong force acting among their constituent quarks, thankfully, overcomes this repulsion and tethers the protons tightly together. But a rather small change in the relative strengths of these two forces would easily disrupt the balance between them and would cause most atomic nuclei to disintegrate. So if you have too much repulsion between the protons, which is not countered by the attraction between quarks that make up those protons and neutrons. And actually, guess what? The neutrons are also part of that picture. The neutrons also are made up of quarks, and those quarks also provide strong force interaction, right? Strong nuclear force interaction. So, left to themselves, the protons would probably not want to be very close together because they're all like charges, they repel each other. But there's also neutrons in the mix of things, and protons and neutrons are both made up of quarks, which interact with each other through the strong nuclear force, and the gluon force carrier particle is literally gluing together protons and neutrons. And this is very important in the heavier elements especially as well, because remember, this is actually important for stars and how stars die, because if it becomes too difficult to keep making more and more stable nuclei, then you're actually going to stop doing nuclear reactions within stars, and that's actually how a star can run out of its nuclear power. Okay. So things like nuclear binding energy and things like that we have talked about in the past are sort of at play with all this, okay? So the protons crammed together in atomic nuclei all repel one another electromagnetically. The strong force acting among their constituent quarks thankfully overcomes this repulsion and tethers the protons tightly together. But a rather small change in the relative strengths of these two forces would easily disrupt the balance between them and would cause most atomic nuclei to disintegrate. Furthermore, were the mass of the electron a few times greater than it is, electrons and protons would tend to combine to form neutrons. So neutrons can actually also disintegrate. Depending on its energy, a neutron can actually disintegrate to make a proton and an electron and some, guess what, neutrinos. So, if the electron was a little bit bigger in mass, then electrons and protons would tend to combine to form neutrons, gobbling up the nuclei of hydrogen, the simplest element in the cosmos, with a nucleus containing a single proton, and again disrupting the production of more complex elements. So if electrons were a little bit heavier and made neutrons a lot with protons, then that could have really disrupted the formation of heavier elements. And guess what? We are made of heavier elements. We're made of things like carbon, oxygen, all that. which are the heavier elements, the Big